Hi friends, in this video, let us analyze the time and space complexity of the insertion sort algorithm. In the previous videos, we have learned about insertion sort and how to implement it. So let us analyze the time complexity first, and let us assume that the array size is 5. Let us see the best case first, and the best case here will be when the array elements are already sorted. So let us see how much time it takes in this best case. So for the outer loop, when I equal to 1, the condition will be true. So it will go inside and checks the while loop condition. And when the while loop condition is checked, that is, if first element is greater than the second one, it will fail. So this condition will be checked and it will be failed. So the inner statements will be skipped. In the next iteration of outer loop, that is when I equal to 2, then also while loop will fail while comparing second and third elements. In the next iteration of outer loop, that is when I equal to 3, then also the while loop condition will fail while comparing third and fourth elements. In the next iteration, when I equal to 4, then also the while loop condition will fail since fourth element is not greater than fifth element. And in next iteration, when I equal to 5, the condition will fail and the execution will be stopped. So we can see that for 5 elements which were already in sorted order, we needed 4, which is 5 minus 1 comparisons only. So in general, for n sorted elements, we require only n minus 1 comparisons. So the best case time complexity of insertion sort algorithm is order of n. So that was the best case, and now let us talk about the worst case. So when will be the worst case happening here? The worst case is when the elements are in descending order and we have to make it in ascending order. So let us see. So for the outer loop, when I equal to 1, the inner while loop condition will be checked and it will be true. That is, to compare first and second elements and they are not in the right order. So while condition will be true and the swapping will be performed. And next, when while is checked, I would be equal to 0, hence the condition will fail. So in the first iteration of outer for loop, the inner loop statement executed one time. Next, when I equal to 2, first while will be checked and it will be true, so inner statements will be executed. Then in second iteration of while loop, it will still be true and the inner statements will be executed. And in third iteration of while loop, I would be equal to 0, so it will fail. So in the second iteration of outer for loop, the inner loop statement executed 2 times. Next, when I equal to 3, first while will be checked and it will be true, so inner statements will be executed. And in second iteration of while loop, it will still be true, so inner statements will again be executed. And in third iteration of while loop, the while condition will still be true, so again the inner statements will be executed. And in fourth iteration of while loop, I will be equal to 0, so it will fail. So we can say in third iteration of the outer for loop, the inner loop statement executed 3 times. Next, when I equal to 3, first, as usual, while will be checked, it will be true, so inner statements will be executed. And in second iteration of while loop, again it will be true, so inner statements will be executed. And in third iteration also, the condition will be true, so inner statements will be executed. And in fourth iteration also, the while condition will be true, so inner statements will be executed. And in fifth iteration of while loop, I will become 0, so the condition will fail. So we can say in fourth iteration of outer for loop, the inner loop statement executed 4 times. Next, when I equal to 5, the outer for loop condition, it will fail. So it will stop its execution. So when size equal to 5, the total time taken is t of x equal to 1 plus 2 plus 3 plus 4. That is 5 minus 1, which is size minus 1. So in general, when size equal to n, we will have t of x equal to 1 plus 2 plus 3 plus etc. plus n minus 1. And we know that the sum of natural numbers from 1 to n is n into n plus 1 by 2. But here, the last number is n minus 1. So we have to replace n as n minus 1. So the equation will become n minus 1 into n minus 1 plus 1 divided by 2. And this minus 1 plus 1 will get cancelled. So this will become n minus 1 into n divided by 2. That is n square minus n whole divided by 2. So we got the time required. Now how can we get the time complexity here? We just have to find the highest exponential and it is n square here. So the worst case time complexity of insertion sort is order of n square. So that was the time complexity analysis of insertion sort. Now let us do the space complexity analysis. So space complexity is the total amount of space a particular algorithm takes to produce the output. So here array ARR takes n units of memory and size will take 1 unit. And I, value and index each will take 1 unit of memory. So the total space S of x is equal to n plus 4. And it is a polynomial and the degree is 1. So the space complexity will be order of n. So that was the space complexity. Now let us discuss about the auxiliary space complexity. So as we learned, auxiliary space is the extra space or temporary space used by an algorithm. So here the array ARR and size are given inputs. The extra memory used by this insertion sort algorithm is for I, value and index. So 1 unit of space for I, 1 for value and 1 for index. So total auxiliary space is equal to 3 units. Since it is a constant value, we can say the auxiliary space complexity of this algorithm is order of 1. And we know that if a sorting algorithm sorts all the elements without using any extra memory or sorts all the elements with auxiliary space complexity as order of 1, then we can call that sorting algorithm as an in-place sorting algorithm. So by that definition, here insertion sort is definitely an in-place sorting algorithm.